Hello, Enriched Algebra 2 students. So today we're going to talk about how to find a slant asymptote, so basically another asymptote that a vertical or that a rational function could have. You're going to want your notes today, notebook, and then two little graph squares as well. So slant asymptotes, when do they occur, when don't they? Because you're not going to have them every single time. Slant asymptotes occur when the degree of the numerator is exactly one bigger than the degree of the denominator. In this case, a slanted line, not horizontal, not vertical, is the function's asymptote. To find the asymptote, we need to use long division, what we've practiced a unit ago. So, first, let's find some slant asymptotes before we even do some graphing. So I have x squared minus 6x plus 7 divided by x plus 5. So what I'm first going to do is set up my long division, because notice the degree is 2 and this degree is 1. So the numerator is 1 larger than the denominator's degree. So let's set up our long division, which we've practiced already. And remember, we always asked ourselves, what times x would give me x squared? Well, that would just be x, right? So x times x, that's x squared. X times 5, that's 5x. And then one thing, we changed signs because we had to subtract that. So x squared minus x squared is gone. Negative 6x minus 5x, that's negative 11x. Drop the plus 7 down. And then something times x gives you negative 11x. That'd be negative 11. So let's multiply. Add. So I will get 62 right there. So no, that's my remainder. Here's the cool thing. Slant asymptotes, all you need is this piece right there. You do not need the remainders. All you need is the equation that comes out of it. So the slant asymptotes equation is y equals x minus 11. That is the slant asymptote, which you could graph. You've done it before. Can graph a linear equation. That would be the slant asymptote. Let's try this one. Notice, degree of the numerator is 1 more than degree of the denominator. So let's go ahead and set up our division. So something times 2x has to give me 3x squared. Now you're probably saying, I have no idea what that would be. So something, so let's call that x, times 2x has to give us 3x squared. Well, I know it's got to be an x, right? So we can we know there's got to be an x. We just don't know the number. So something times 2 has to give me 3. So if I divide by 2, it looks like x has to be 3 halves. So actually it's going to be 3 halves x times 2x should give us 3x squared. Okay? 3 halves x times 6. That's 3 halves x times 6. That's 18 over 2, 9x. Right there. Let's subtract. So change signs. I'm going to get negative 8x minus 2. So something times 2x needs to give me negative 8x. That's a negative 4. And then negative 4 times 6, that's negative 24. Change some signs. Positive 22. So my slant asymptote is 3 halves x minus 4. Right there. Now, let's put this in perspective. Let's actually do and graph it when we have a slant asymptote. So I have x squared minus 2x minus 3 divided by x minus 2. So, very first thing, let's see if we can simplify. Which I think we do. X minus 3, x plus 1 on top, over x minus 2 on the bottom. I have not a single whole, nothing canceled off. My roots, aka my x-intercepts, set the numerators equal to 0. So x equals 3, x equals negative 1. Let's mark those in. There we go. My asymptote, denominator equal to 0, because this is my verticals. So x minus 2 equals 0. So x equals 2 is my vertical asymptote. Graph that in here. There we go. T squared. Do I have any tangency or togetherness? No duplicates on the top, no duplicates on the bottom, none there. So we know that everything's going to be going different ways, no bouncing. End behavior. Notice, guys, it is a slant asymptote. One more than the other. So I am top heavy. We need to do some long division. So I'm going to do some long division up here. Looks like it's an X. Change some signs. Gone, gone. I'm left with -3. So it looks like my slant asymptote is y equals x, which I will graph in. Starts at 0, 0, and then follows up 1 over 1 the entire way. Whoops, missed a little bit. There we go. Y-intercept, that'd be -3 times 1 over -2, aka 3 halves. So 0, 3 halves is a dot on my graph. That would be right here. Alright, so I know that the ends, the things going to -infinity and infinity, have to follow the slant asymptote, because that's my end behavior. So on this side I have 2 dots, so I can kind of follow. And I know that this end piece has to follow my slant. Then this side has to follow my vertical asymptote. Now, I know it can't be up here because I know it's not together. There's no togetherness here. So I do know I have to be going downwards. Then on the right-hand side, I need to follow that slant asymptote. So still kind of have that boomerang look to them. However, you still kind of have a different look to it. Let's talk about our domain. Domain now, guys, it's not the slant asymptote that's causing us an issue. It's only the vertical. So only a problem at 2. And our range. The slant asymptote is not causing any problems with the range, because notice, guys, even though I can't get down on this side to -5, I did over here. So my range for this particular graph is -infinity to infinity, because I'm able to go all the way down and I'm able to go all the way up. Let's try one more. So let's do some simplifying. Numerator, it looks like an x can come out. Denominator is just x plus 1. Nothing cancels, so no holes. Let's find my roots. I got 2 pieces in the roots. I got x equals 0 and x minus 1 equals 0, because I do need to worry about both of those. So I have ordered pair of 0, 0 and 1, 0. So let's mark those in here. Okay. Asymptote, my vertical denominator, equal to 0. So that's -1. Let's go ahead and mark him in. Alright. Tangency? None. End behavior. I do have one more than the denominator, so I do need to do some division. Now be careful, guys. There is a piece missing on the end of here, so I am going to put a +0 at the back end so I do not forget. X times x will give me x squared. Change my signs. I get -2x plus 0. -2 times x gives me -2x. -2, change some signs. I'm going to get a +2. But my slant asymptote is at x minus 2. So let's go ahead and graph that line. Put some dots so I don't kind of get lost here when I draw my dotted line. There we go. Okay, got my slant asymptote in there. Y-intercept, because we need a little bit more dots. I feel like we need some dots here. I have 0, 0. Okay, let's figure this out. What's going to happen? I got some information over here. I do know as I go off to infinity, I do have to be following my end behavior, aka this guy right there. And I know I need to cross here, but I can't cross that. So it looks like what it's going to kind of do is kind of do a bump and then shoot off with my vertical asymptote. So there's kind of my boomerang. Now guys, I can't be boomeranging on this side because then they'd be going together, and I know that they don't go together based on my T. So I do know I have to come up this way, and then I need to follow my slant asymptote back down. So that would be my answer here. Let's look at our domain. The only issue I have is -1. And then my range, we get to have everybody. No issues there. And that's the end of this video. See you later, Sabers.